Number 15. What is meant by an induced dipole? An induced dipole is an instantaneous dipole in a non-polar molecule when the molecules, the electrons are momentarily attracted by a polar molecule. So there's something that's polar. There's something that is polar, which causes, right? So there's a partial positive end, there's a partial negative end. That partial positive or partial negative end is going to affect the distribution of electrons in a separate molecule that is in fact nonpolar. There is not a partial positive end. There is not a partial negative end in this nonpolar molecule. But because the electrons, which are normally evenly distributed in that nonpolar molecule, because those electrons are going to respond to either the repulsion or attraction from this other polar molecule, the electrons in the nonpolar molecule will rearrange themselves so that they're no longer evenly distributed. They'll either be attracted to the partial positive end or repelled by the partial negative end. Either way, that is going to induce or cause a dipole, right? A polar aspect in a molecule that is otherwise non-polar, but it's caused by another molecule. Another molecule causes this molecule, this nonpolar molecule, to show an instantaneous induced dipole. And what is the everyday importance of this type of intermolecular force, right? The induced dipole. What is important about the induced dipole? Well, induced dipoles account for the solubility of nonpolar compounds like oxygen in polar compounds like water. Now, normally, if you just think this through, normally something that is nonpolar, like O2, all right, molecular oxygen, the stuff that you breathe, the stuff that every other animal breathes, okay, normally it wouldn't be able to dissolve in something that is polar, like water. Okay, I know we haven't gone over solubility rules at this point in the course, but there is this general rule that says like dissolves like. And so you'd think that nonpolar compounds can only dissolve in other nonpolar compounds. And then conversely, polar compounds can only dissolve in polar compounds. But here we see a nonpolar compound successfully dissolving in a polar compound, oxygen dissolving in water. Now, this most certainly happens, or else fish would die of suffocation. Right? There's oxygen in water. But that induced dipole is caused by the polar nature of the water, the partial positive end, the partial negative end, forcing the electrons in that O2 molecule to pick a side. They're either going to lean towards one end or the other, creating an induced partial positive end and an induced partial negative end. That is a nonpolar molecule, but in this instance, it is acting as though it is polar because it's been induced to do so.